Hi all, this is Bayretti Sairavareti and today we are here to discuss about the minor project detection of handwritten characters using neural network. My teammates are Pulgam Sandeep and Gautam Krishna. Today I'll take you all through the project in a brief manner. First of all, the project is handwritten characters using neural network. We have used a dataset from Kaggle. We have downloaded that and saved that to our Google Drive and link that to the Google Colab. First and foremost thing is that we have included all the required frameworks like NumPy, OpenCV, Keras, TensorFlow, which is used for pre-processing, and Matplotlib for plotting the graphs and pandas. Next, we have downloaded the required dataset, that is this dataset. It is at handwritten data .csv from kaggle.com, and what we have done is we have set that to a Google Drive in a folder. Next, in Google Colab, we have linked the drive in which the data is saved. We have mounted that to the Google Colab, and here we have included the path and the file location where the file is present. The data set file is present, and we have read the data here. In in this cell we have in this particular cell we have split the data into images and their corresponding labels like zeros and ones in x and y manner, and in the next cell we have reshaped the data which is present in the CSV file, so we can display we can display the data in forms of image. And in this particular slide we have included a dictionary. Why? In the sense, all the labels are present in the form of floating point labels, so we have to convert that into integer values. So we have created a dictionary where we can map the integer values with the characters, so we can identify the what the character is easily. And and in the next slide we have reshape the training and test data, so that we can use the training data and the testing data to train our model and respectively test our model how the performance is and everything. The training data, the amount of data used is 29,760, that is 2,97,960. And next we have converted the single float values to categorical values. This is done so that the CNN model takes the input of the variables and generates the output as a vector of probabilities. It can link these values to the dictionary which we have provided. And here and here we have created a CNN model. In this particular CNN model, we have used max pool layers, which are used to reduce the number of features extracted. Like we can extract a multiple number of features. So from that, we have extracted the required number of layers using this max pool and flattened that data. And in this and here we have given the epoch which is to train the data. We have trained the data in what we say 5 iterations, and we have used ADAM optimizer, that is a combination of RMS and adagram optimizing algorithms. So the data set is large, and we have used this Adam optimizer so that it is somewhat efficient as compared to others, so we can get a expected output in a better manner. And we have given 5 epochs, that is we have run the 5 time train the model in 5 iterations. We have saved the particular generated trained model into our drive location, and we have named that as model v5. So we can see in our drive, we can see under it is at handwritten character C. Uh, we have generated the model v5. We have saved that model and here are the files related to that model. Now for the trained and test data, we are getting the accuracy of around 98.59%, 98.59%, and the validity accuracy and loss are around, loss is around 63 and 65, 7.5 to 6.7, like in that range, and accuracy is around 98, 97 to 98%. Here we have test the data on our what we say, we have predicted the model, how the model is working using the test data. We have divided the data into test data and training data. So using that test data, we have predicted how it is, how we are getting the output, whether we are getting the correct output or not. Here the output, here we are getting a correct output, like for n it is predicting s, and for t at t c c. So it is giving a correct output for the test data. Here we can see that we got a correct output for the test data. Now we are going to predict on the external data. Here we are loading the model, which we have saved the model earlier in our drive. We are loading that, and we are importing the cvt.im show, and we are getting the data from our drive, like external images from our drive. This is the drive path, and these are the file names. We have saved the file names as .jpg and .png, .jpg, the photographs formats, and we have named them. Now we have read the data from we have the read external image, that is alphabet B, and made a copy of it so that we can go through some processing to be fed through the model. And the image read is then converted from like a PGR representation, as OpenCV only reads the image in the PGR representation, to and we have converted that BGR to RGB for displaying the image. And earlier we have trained the data for a particular dimension of output, like input and output. So we are resizing according to that input and output. And after that we are making processing the copied image which we have copied. Image we have made a copy, so we are processing that image and converting the BGR to grayscale, and we are thresholding it. Like, thresholding is not mandatory, but we are doing that. We can directly make a prediction on the grayscale data. We, but if we do the thresholding, the image will be can be kept smooth without any sort of like gray colors and everything. So it will be a clear image. We are again reshaping that threshold image, and we are predicting the image by comparing that to the word dictionary which we have provided earlier. And we are getting a prediction, like see, for the image which we have read, we have read an image like b.jpg, we are getting a correct prediction that this is alphabet character is B. And you can see for multiple inputs here, we are getting for A, like B we are getting for A. And now let's try for M. We are getting for M also. So we have successfully developed a model which by which we can detect predict the handwritten characters. And the accuracy we got is around 98.59. So let's take 98% accuracy we got, and this is a minor project. Thank you.